Now let's work out a slightly more involved example. So here we're trying to convolve two signals x of t and h of t. X of t is given by u of t plus 1 minus u of t minus 1, and h of t is e raised to minus t times u of t minus u of t minus 1. So let's begin by thinking of these signals as x of tau and h of tau, and let's try to sketch them to get a feel for what's going on. So we have x of tau, which is a signal if I were to sketch it, it looks like this, right? Because u of t plus 1 is a function that would have been 1 for all values of t greater than minus 1, and u of t minus 1 is a function that is 1 for all values of t greater than 1. So when I subtract the two, for all values of tau greater than 1, x of tau is going to be 0. Okay. And how about h of tau? Well, h of tau is an exponential, but only between 0 and 1. So e raised to minus tau. Okay. So what's the next step? The next step is to flip h of tau about the y-axis to form h of minus tau. Maybe I will even write h of minus tau here. So now h of minus tau is a function that goes between 0 and minus 1, and in this range it is given by e raised to tau. Okay. Okay, now what I want to do is to find h of t minus tau and then multiply x of t, or rather x of tau, with h of t minus tau. Okay. Now the issue here is h of t minus tau and x of tau may or may not overlap depending on what t is. So if t is very large and negative, what I'm going to get is I'm going to take h of minus tau and we're going to shift this to the left. So we're going to shift it by t, right? So whatever is 0 here now occurs at t, and whatever is at minus 1 now occurs at minus 1 plus t. So this is h of t minus tau for large negative values of tau. Now when I try to form the intermediate signal wt of tau, I'll be multiplying both these two things together and you're going to get 0, right? So what do we have? You're going to get 0, and suppose I start to increase the value of t. So I'm shifting it by smaller amounts to the left. And then what happens is this whole curve moves to the right. At some point this is going to start to overlap with this, and that's going to occur when t is equal to minus 1, right? When t is equal to minus 1, what's going to happen is that h of t minus tau, or h of minus 1 minus tau, is going to look like this. Okay. So what I can say is that let's write it here. W sub t of tau is equal to 0 for all values of t less than minus 1. Okay. Now the interesting question comes, okay, what is the next range of t values that I want to consider, and what would be the form of w sub t of tau? See, notice what's going to happen is this. As you shift this thing to the right, see how this overlaps with x of tau. So what it's going to look like this. Right? Until this point coincides with minus 1. And notice this point is actually minus 1 plus t. So the next range of t that I want to consider is actually values. So notice this is going to be t, this is minus 1 plus t. So what I want to consider are values for t greater than minus 1, but I want minus 1 plus t to be less than minus 1. Okay? That means t has to be smaller than 0. So the next range of t I want to consider is minus 1 less than or equal to t less than 0. Because in this range, I can write a nice expression for wt of t, and that's going to be, so this function is going to look like this, right? Yeah, maybe I'll draw slightly better. So this is minus 1, this is t, and this function, what is this function? So this, you have to be a bit careful to figure out what this function is, right? We started with h of tau, which is e raised to minus tau. H of minus tau was e raised to tau. And this is h of t minus tau. Okay? So what is this? I obtained this by replacing tau by tau minus t. So it should be e raised to tau minus t. Okay? So the function of, so w sub t, so the expression for wt of tau is equal to e raised to tau minus t for all values of t between minus 1 and 0. Okay, so what's the next range of t that I want to consider? Well, the next range of t I want to consider can be obtained by doing this. Oops. When negative 1 plus t falls here, suppose this is t and this is negative 1 plus t. If this happens, then you can write a nice expression for so in this case, so this happens when t is smaller than 1 but bigger than 0, right? Because if t is greater than 1, then this part of it starts to get cut off. So the next range I want to consider is t between 0 and 1, and in this range I have a x of tau, which I have a x of tau which looks like this, between minus 1 and 1, and I would have something like this for h of t minus tau. So this would be t, this would be minus 1 plus t, or t minus 1, and this would be e raised to tau minus t. So wt of tau is e raised to tau minus t, but now the range I should be more careful here. So this is for tau between minus 1 plus t less than or equal to tau less than or equal to t. And this, actually here I should be, this is true, but this is actually not the expression for all values of tau, right? So this is only for tau between minus 1 and t, because otherwise this is 0. So this is a range. I think the range is already here, so I'm not going to write it again. Again, the range is already here, so I'm not going to write it again. The range is already here, so I'm not going to write it again. So on the last one is when t becomes greater than 1, but it's less than 2. Actually, this is not the last one. There's one more. So in this case, I have a x of tau which looks like this, and then my h of t minus tau looks like this. So this is t, this is 1, this is minus 1 plus t. So here wt of tau is equal to e raised to tau minus t, but only for values of tau between minus 1 plus t and 1. So basically only for this part, because this part goes away, becomes 0 because it gets multiplied by 0. What happens? The last case is when t is greater than 2, because when t is greater than 2, this thing gets shifted to the right to a point that now it starts to look like this. So t has become greater than 2, so minus 1 plus t has become greater than 1. Two is somewhere here, this is t, this is minus 1 plus t, and now they do not overlap at all. So w sub t of tau becomes 0 for all values of tau okay. Now I think I should have been more careful when I wrote this, but please stop the video and just ponder about this. We are describing signals w sub t of tau. So really we are describing this signal to be of some form for various values of tau. Okay. But this form changes when t changes over as t goes from minus infinity to plus infinity. Okay. So in this range of t, this is the function wt of tau, and this is 0 for other values of tau. Okay. Now all that remains is to compute y of t by integrating wt of tau over all these different ranges. Okay. So what's going to happen is, okay, I will just do the integral right here, so it'll be easier for us to see this. So for this range of t, which is basically t less than minus 1, w of t is going to be equal to 0. For this range of t, t between minus 1 and 0, y of t is going to be integral of wt of t between minus infinity and plus infinity. But notice that this signal is non-zero only over this range of tau. So only between minus 1 and t I get integral e raised to tau minus t d tau. Okay. Now you can perform that integral. So that will be e raised to tau minus t between minus 1 and t. So just to make it clear, let me copy this up here and then erase this. So this becomes 1 minus e raised to minus 1 minus t. So again here I'm going to get integral of w t of tau, but notice now the limits of the integral are between minus 1 plus t and t e raised to tau minus t d tau. Now one of the common mistakes I've seen students do is to put dt here instead of d tau. Be very careful, it should be d tau because we are integrating w sub t of tau with respect to tau. And so this, again what we're going to get is 1 minus e raised to, so let's do the, it's e raised to tau minus t between minus 1 plus t and t. When I plug in the upper limit I get 1. When I plug in the lower limit I'm going to get e raised to minus 1. And the last one, I'm going to get the same thing. Now, however, this will be integral between minus 1 plus t and 1 e raised to tau minus t d tau, which is e raised to tau minus t between minus 1 plus t and 1, which gives me at the upper limit I get e raised to tau minus 1. At the lower limit we get e raised to minus 1. And then here y of t is 0. Okay, so the final answer is be careful, I think I made a mistake here. 1 minus t. Yeah, I actually make a mistake which I tell students not to do. Remember, the final result has to be a function of t. It cannot be a function of tau. If you're finally writing y of t in terms of tau, then you are making some mistake somewhere, right? Because finally we need to get a function of t. Okay, so we can combine all this together and then we can write the final result as follows. So y of t is defined piecewise. It is 0 for all values of t less than 1. We get that from here. Now when t is between minus 1 and 0, it's 1 minus e raised to 1 minus t. So it's 1 minus e raised to minus 1 minus t for minus 1 less than or equal to t less than 0. Now when t is between 0 and 1, it is 1 minus e raised to minus 1. And when t is between 1 and 2, it's given by e raised to 1 minus t minus e raised to minus 1. And it's 0 for all values of t greater than 2. So this is the final result. Okay. Now let me roughly plot this and see whether this actually appeals to our intuition. Okay. If I plot this, let's see what we're going to get. So you're going to get 0 until t is minus 1. Then what happens is it increases to what happens to 1 minus e raised to minus 1 between minus 1 and 0. And then it actually stays that way until t is 1. Okay. And then it decays to 0. Then it decays to 0 at t equal to 2. And then it stays at 0. Okay. Now let's see whether this makes sense, sort of makes sense, if we start with the we start with the x of t and h of t we had. So we had x of tau was between minus 1 and plus 1, and h of tau was so when I flip h of tau, I got something like this. Okay. Now clearly when I shift it to the left by, okay, let's write this is -1 0 1 -1 0. If I shift it by any more than -1, I get 0, so this makes sense. After that, there is some overlap between this function and this, so we get the integral of this. That increases. That makes sense. But once I've shifted it by more than by 0 or between 0 and 1, notice that this value should not change at all, because if I shift this function anywhere between here and here, right? If this function is strictly contained within this window, then the value should not change at all. That's why this thing stays constant. This stays constant at 1 minus e to the minus 1, and after that the overlap starts to decrease, so the function decays to 0 after that. Okay, I think it's a good idea to check your result and make sure that it kind of matches what you expect this to do.